So it is finding the angle using trig. Okay, so I've got a couple of examples to show you, and then I will ask you to do a few, and then we'll do our own kind of practice. So first thing I want you to do is make a quick sketch of this example one, this first triangle. So I've got a nice right angle triangle. You'll see the difference in this one. I'm given two sides here. I'm given 12 centimeters and I'm given 14 centimeters. I'm not given this angle. That's what I'm trying to find. So make a sketch of that triangle, please. Mark on that information, and then we will run through this problem. It's going to work out basically the exact same. The first kind of 80% of the question is exactly the same as before. It's just at the end there's a slightly different process to finding the angle. So I've got my triangle drawn hopefully now and marked on the information, so I can now label it. So I've sketched it, now I'll label it. So same as always, hypotenuse is the side across from the right angle. Wherever the angle is, you go to the opposite side, that is the opposite side, and the side next to the angle is the adjacent side. Okay, now we're going to do our SOHCAHTOA to figure out which of the trig functions that we are going to use. Probably some of you are getting to the point where you could tell kind of straight away. We don't have the hypotenuse, so it can't be either sine or cosine. We have the opposite, we have the adjacent, so it is tan. So again, no different from before. We are writing down what the ratio is. It is the tan of this time the angle is x, and that is equal to the opposite side over the adjacent side. So it is the tan of angle x degrees equals to the opposite side is 12 divided by the adjacent side, which is 14. Okay, now I'm going to pause for a second. You all need a calculator or a scientific calculator on your phone or on your computer, laptop, whatever it is, because we are about to use a function that we've never actually used before in a calculator. I don't think you will have used before. Okay, and I'll explain a wee bit of it. To get this angle x, to solve for this angle x, basically this time I have to undo the tangent function. Okay, Charlotte's, I've just got a message. Charlotte, did you leave us there, but you're back now? Okay, a few of us now join us. Thank you for joining us. You need to catch up by copying down this example. I've got one more example after this, so if you kind of missed the first half of this, it's okay. We've just started by drawing a triangle and labeling it and using SOHCAHTOA, and we've now got down to this line here where the tangent of x degrees equals 12 over 14. Now this is quite hard for me to show you without being in person, but what we have to do now in order to solve for x is use, and I'm just going to write this called, use the inverse, use what's called the inverse of tan, right? So there's a little bit I need to talk about. If you have an actual calculator in front of you, if you look at where sine, cosine and tan is, you should see that above tan, kind of in a shift function or a second function in your calculator, there should be something that looks like tan to the -1. Okay, if you're using a scientific calculator on your phone or on your laptop, there may be a little button that says INV. INV. If you click INV, your sine, cosine and tan should switch to sine to the -1, cosine to the -1, tan to the -1. Okay, and we need to use that function here in order to find this angle. Okay, we have to use the inverse of our trig function. Okay, so if you're having problems seeing that, using that, this is going to take a wee bit of getting used to try and get, if you're using a calculator or your phone or whatever, to try and get this to work. But I'll just show you show you what to do. So we're going to use the inverse of tan. So our next line of working is to say that x degrees equals, now rather than hitting the tan button, we need to hit the button that says tan to the minus 1, or the inverse of tan. So it is tan inverse of tan, and then once we do that, we just put in the brackets this fraction, 12 over 14. Right, and I think if I maybe, yeah, try and do that for yourself, and if you're struggling, can't find the inverse tan button, then let me know. But it's in my calculator, the tan to the minus 1 is in yellow above the actual button, so I have to click shift and then hit that tan button, and it comes up saying tan to the minus 1, and then I can just do 12 divided by 14, and it should give me the answer. Now, if you're using a calculator on your laptop, make sure that the angles are in degrees. So up the top, like in the one in Google, if you're just typing in scientific calculator in Google, on the very top left it says RAD and it says DEG, and you can only select one of them. Make sure you select DEG, because if you don't, it's going to give you the wrong number. But in your phone, it should automatically be in degrees. So if you are able to do the inverse tan of 12 over 14, what it should give you is an angle of 40.6 degrees. Now, I know that's totally new for all you. Can you give me a wee hands up function, or say yes in the comments if you manage to get, like, put in the numbers and get that answer? Okay, good, a few of us. What are you using, Molly? Yeah. Right, there's one that says LN. That's like a, does it look like a capital I then a small n? Is that what you're talking about? Because that might be a different button. Okay, there has to be though. Are you? What else are you using? Are you got a laptop or anything else at all? Right, can you go to the scientific calculator and Google please on the laptop, because if it's not, you should be able to get it somewhere on your phone, but if you can't get it on your phone, you're going to need to use a laptop. Yeah. Okay, so you see it now? Yeah. Okay, it should come up saying like the tan into the minus 1, and then you just put in your fraction 12. I just put 12 divided by 14, and then that should give it. Okay, thanks Eva. Can anybody tell me, anyone else that's having difficulty getting this answer, that's difficulty finding the inverse? Can you let me know now? Alright, let's try another one then, another example. Now that we hopefully know what to do with this inverse, we'll try another example now. So 40.6 was the first one, let's try another one together. So we've got this kind of real life example for our second example. So we've got a picture which shows a lamppost 5.6 meters long. As you can see, that distance is 5.6 meters. It's toppled over and come to rest against the top of a wall 4.7 meters high. Calculate the size of the angle between the lamppost and the ground. Okay, so in this case, if you're given like a real life problem, what you're going to have to do first is kind of draw your own triangle. Okay, so we don't have I mean, we can see there is a right angle triangle there, but it's not kind of that clear. So first thing we're going to do is draw our own triangle with this information. So can you do that now? So it's a kind of tall, triangle, kind of like that. Try and make it neater than mine. So I've got my right angle there, I've got that this distance is 5.6 meters, and I've got that this vertical distance is 4.7 meters. Okay, sorry that's so messy. Right, I can now label things. So across from the right angle is my hypotenuse. Oh sorry, I need my angle in here, which is x degrees. Across from my right angle is the hypotenuse. Across from the angle x is my opposite side. Next to my angle x is the adjacent side. So you can now use SOHCAHTOA to select the correct trig function. Only this time we're looking for the angle, we're not looking for one of the sides anymore. So I've got the hypotenuse and I've got the opposite side. Therefore it's SOH, which means it is sine that I'm going to be using. So we'll write down the ratio the same as before. So it is the sine of the angle x degrees equals opposite over hypotenuse, O over H. Now fill in what O and H are. So the sine of x degrees equals opposite is 4.7, H is 5.6. Now because we're looking for the angle, we have to undo this sine function, which is connected to the angle, to get x on its own. So x degrees is equal to the inverse of sine of 4.7 divided by 5.6. So now go to your calculators and hopefully you'll be able to put that in okay. So the inverse of sine of 4.7 divided by 5.6. Put a comment in or shout out if you get an answer. If you're not talking to me, then put your answer in the comment, please. Okay, got one answer from Tiana, 57.0. Sam, I don't know if you've got your hand up or if you've just left your hand thing on. If you're wanting to ask a question, right, okay, that's fine. Right, only one person got an answer.
I don't think it's working for me, like the answers aren't either.
Okay.
But like I've done that, and so when I've got like 0.8
yeah, see, so see the very top left, it will say RAD and DEG. Make sure it's clicked onto DEG. It's really, yeah, no, it's really annoying that kind of exists because it makes our lives a lot harder. But just always make sure it's clicked onto DEG, and that should be you should be able to do it now if you do the same thing. What about Charlotte, Travis, Sam, Eva, Amy in the comments? Are you getting an answer or are you struggling with a calculator? Okay, Travis, you've got an answer. I presume that means you do have an answer. Sam Edgar, what about you? Okay. Molly, did you get an answer this time?
Yeah, I've got like the same as Tiana.
Right, so Sam was saying, yeah, that's fine if your mic isn't working, Sam, just put a wee text, comment in. Had the same problem, so using radians, but if you make sure it's in degrees. So then, yeah, the answer you should get is 57.06. Okay, so So 57.06 is the answer, 57.06. So if we're going to round to one decimal place, which we should, that's going to be 57.1. Okay, but if you've put 57.0, that's fine. I'm just happy that you can use this inverse function. Okay. Eva, yep, I got your message, says that you're lagging. If you can't quite follow, I'm recording this, so you can go back and just listen to me going through it again. So hopefully that should be okay for you. Right. Any questions just now? I've got two questions I want you to do just now while we're in the call, and then we'll go over them and we'll check all the answers together. Anyone get any questions about this at the moment? Right, okay.